All right, in today's podcast, we're going to talk about the different types of chemical reactions, and there are 5 different types. So we're just going to go right into this. The first one is synthesis. A synthesis reaction is where you take 2 or more elements or compounds and you combine them to make one product. So the general reaction we wrote here is that A plus B would give us AB. The key to a synthesis reaction is that there is only one product. That's how you know that it's a synthesis reaction. So if you have one product, and remember the products are to the right of the arrow, then you know that you have a synthesis reaction. This could also look like A plus BC giving us ABC. So it doesn't have to be just elements over here as reactants. It could be an element and a product. But as long as they're all coming together to give you one product here, then you know that you have a synthesis reaction. And we have an illustration on this page right here that kind of shows you that. You have a cat and a fish giving you a fat cat because the cat ate the fish. So 2 things coming together to only give you one thing. The next type is a decomposition reaction, and decomposition reactions are the opposite of a synthesis. So with the synthesis reactions, we had one product. With our decomposition reactions, we need to make sure we only have one reactant. We're taking the one reactant and we're breaking it down. We could be breaking it down into elements or compounds. So in the general reaction that we wrote, we have AB as our one reactant breaking down into A and B. Again, this could be A, B, and C, and it could be breaking down into A plus BC. So this doesn't just have to be elements over here on the product side. It could be an element and a compound. It could be 2 compounds. It's just the key that you have one reactant that makes it a decomposition reaction. The example illustration here, you have an unhatched egg on one side breaking into the empty hatched egg with the chick. So one thing breaking down into the parts that make it up. The next type of reaction is a single replacement reaction. And single replacement reactions are where you have a compound and an element, and you're producing another compound and an element. What you're going to see is that these things are going to switch places. So I have my compound A and B, and then my element C here. The B and the C, all they did was they switched places. So the C came in and joined with the A to make a new compound, and then the B got kicked out by itself. So that's how you can identify the single replacement reactions. It's a compound plus an element giving you another compound and an element. And those are the only those are the only reactions that will look like that. The illustration for this one is if you have a dog with a bone, that would be like your compound, and then you have a steak, which would be your element. The dog is going to switch. It wants the steak more, so it's going to take the steak and it's going to drop the bone. So the steak and the bone switch places, and that's how you could illustrate a single replacement reaction. A double replacement reaction is a lot like a single one, except you have 2 compounds instead of a compound and an element. So our example here, we have A and B and C and D. Well, if you remember with ionic compounds, the positive part always comes first and the negative comes second. So the C must be positive and D must be negative. A and C cannot go together, ever, because they're both a positive charge. B and D can't go together because they're both a positive charge. So when we're doing these double replacement reactions, the outsides will always go together and the insides will always go together. So the A will always join with the very end of the final compound, and the C will always join with the end of the first compound. And that's how we ended up with these over here, because remember A was positive, D is negative, C is positive, and B is negative. So you got to keep those positive and negatives equal, and then that means that the outsides and the insides are how they will switch. So 2 compounds exchanging elements, that is your double replacement reaction. And the example they gave us here is a bunny with a steak and then a dog with a carrot, and then they just switch which food they have. So the rabbit ends up with the carrot and the dog ends up with the steak. That would be your double replacement reaction. Combustion reactions are probably the most fun reactions because these are the ones that always are exothermic. That means they're releasing a bunch of energy and a bunch of heat, which you see as fire, explosions, and things like that. So with a combustion, you take a fuel and you burn it in the presence of oxygen to produce carbon dioxide and water. Sometimes you get some other byproducts, but for us, we're going to ignore that, and you're always going to get carbon dioxide and water. So our example here, fuel, and fuel is usually C some number H some number. So it's usually made up of carbons and hydrogens. It can also have some oxygens thrown in there, and that will work too. So make that a Z. But usually it's a carbon and a hydrogen for your fuel, reacting with oxygen to give you CO2 and H2O. This part of a combustion reaction never changes. It's always reacting with oxygen to give you CO2 and H2O. So the combustion reactions, the only part that changes is the fuel that you combust. And that's how you can identify a combustion reaction. We have some examples here of each type. So we have our single replacement up top there. You have your element magnesium reacting with oxygen, and it gives you magnesium oxide. Remember, the key with the synthesis reaction is that you get only one product. Decompositions are opposite, so in that case we're looking for only one reactant. In this case it's water breaking down into hydrogen and oxygen gas. The single replacement reactions, you have the element and the compound, and in this one it's the aluminum and the copper that are switching places, so that's your single replacement. Double replacement is where you have two compounds switching elements or switching polyatomic ions, so the iron and the carbonate will go together, and the sodium and the chlorine will go together, outsides and insides. And in our last one here we have methane combusting. Methane is CH4, that's our fuel. It's burning in the presence of oxygen and is giving us H2O and CO2 as our products. So that's how you can tell that that one is a combustion. Okay, so in this one they want you to identify the type of reaction. Alright, so what I look for are just kind of the keys for everything that we just talked about. Since this one only has one product, that tells me that this must be a synthesis reaction. If I look at this one, I have an element and a compound giving me an element and a compound. If I look closely, I can see that the magnesium and the hydrogen are switching places. The magnesium's coming in, it's kicking the hydrogen out by itself. So this would be a single replacement reaction. Here I have two compounds, and these usually are the really long looking ones that tell you that it's a double replacement. It's a double replacement because the lead and the chromate are going together, and the potassium and the nitrate are going together. So you have two compounds reacting. In this one I have only one reactant, and one reactant indicates that it's a decomposition reaction. It's breaking down into its different parts. This one I have an element and a compound, giving me an element and a compound. So like we said before, that would be a single replacement. The iron is coming in and it's kicking the copper out by itself. So they're switching places. And in this last one, I have O2, CO2, and H2O. And this is the example that we just gave earlier, but that is the combustion reaction. There's our fuel reacting with oxygen to give us CO2 and H2O. Okay, so that's it. Make sure you can identify kind of the key points for each type of reaction so that you can tell what it is. And then we'll do some practice with these in class, and we'll also start learning how to predict products of these different types of reactions.